Hello, Dr. Sanders. This assignment will be covering FluidSimulation.java. So I'll run the code and it'll run without any errors. And it opens up, and whenever I hit the arrow keys, you can see that the particles will jump up if they are on the surface. If they're not on the surface, then they're not affected and they just continue falling to the pan. I also changed the way that the y variable is going to prevent the particles from leaving that y coordinate, that y level. So now they are freely moving. And whenever I change pan tilt, you can see that they have to catch up to fall onto the pan. And then if they fall past the pan, their velocity is set to 0 and they just stay on the bottom there. I will talk about the code now. So first we have this line of code here, float pan surface y. We have this line, we have this method that we're calling, and we're going to figure out where the floor is, where the particles are going to be resting. It's going to be the y value of the surface right under our cake pan. And x and c is going to be the object's current position. And then the tilt is tilt x and tilt c. So next, this line here. So distance from center, we're going to be calculating using float math.square x times x plus z times z to calculate the distance from the center of our object. We're doing this in order that we can have more realistic, more natural splashes. So we're going to have this calculating the center, the distance from center, and then splash factor, which is going to be that distance turning it into a value that's going to be between um, 0 and 1. So that means we're going to have particles that splash or particles that don't splash based on where they are on the pan to have more realistic splashes. So now in these lines, we're detecting sudden movements based on our tilt. So float tilt change x equals math.abs tilt x minus previous tilt x is simply figuring out when there's a sudden change in movement. It's just subtracting the tilt from now based on where it was, and so that gives us how much the tilt is currently. Then float tilt threshold equals 1 sets a limit, 1 in this case. So it checks if the tilt is bigger than that. So if you basically jerk the pan, then more than 1 degree in any direction, it's going to turn this to true, and that's going to allow the particles to then splash. So here, so if the splash, it's going to now calculate from using that variable we calculated before, distance from center. We're going to use that to now see which particles should splash and how far they're going to splash to just make a more realistic physics simulation here. So if sudden tilt and y is less than or equal to pan surface y plus 0.01 float, so if the object is super close to the surface and it's also going to be close to the edge, then it's going to splash. So this is going to start with a base upward speed of 2, and then it's going to add a little more based on how large the sudden jerk was. Um, so all this together is going to figure out where the pan surface is, and then it's going to figure out the distance from the center, and then it's going to measure whether it should splash or not, and then based on the tilt, suddenness or amount, then it's going to see how much speed particles should have to bounce off the surface. Thank you.